In this video, we're going to see how to take the integrals of polynomials, as well as come up with a formula for the integral or the antiderivative of power functions. So, first off, the rule for the antiderivative of power functions, if I have the antiderivative of x to the n dx, the idea is I'm going to add 1 to the exponent, x to the n plus 1, and divide it by that new exponent. And the reason, so I'd put a plus c in there, the reason for this is if I were to take this thing's derivative, I'll multiply this out by n plus 1, and the n plus 1s will cancel, and I'll be left with x to the n. And with this rule, in order to take the integral of a polynomial, or any linear combination or some addition or subtraction of power functions, you will just need to, let me say this, apply the formula to each term separately. Now, one thing to consider here, though, is this formula only works for n not equal to -1. You can clearly see if n is -1, if I'm taking the antiderivative of 1 over x dx, that is the integral of x to the -1 dx, and if I try to use this rule for that, when I add 1 to this exponent, I'll try to get some x to the 0 over 0, and that is undefined. Whereas, if I took the antiderivative of 1 over x squared, that's the same as antiderivative of x to the -2 dx. And this works just fine. -2 plus 1 is -1. Divided by -1, put a little plus c, and I could clean this up. Alright, a couple of examples, I guess 3 examples. Evaluate the integral from 0 to 5 of 8x cubed dx. And so first, I'm going to do the antiderivative of 8x cubed, so I'll just bring down the 8. I'll add 1 to this exponent, so it was a 3. I'll put it to the 4th, and divide by that new exponent, 4. So that's going to be evaluated from 0 to 5, which will equal 8 over 4 is 2, so I can bring that down a bit, 2x to the 4th, evaluated from 0 to 5. I recommend reducing as much as possible, as early as possible, because that'll make the later computation easier. But you could have done it here and reduced at the end. It just wastes you some time. So I put in the 5, so 2 times 5 to the 4, minus 2 times 0 to the 4th. 5 to the 4th is 625, times 2 is 1,250. 0 to the 4th is 0. Times 2 is 0. So my answer is 1,250. Second example. And this one I have a quadratic. I have 3 different terms. So I just treat them each separately. So I'm going to take the antiderivative of each term. So I add 1 to this exponent and divide by that value. I add 1 to the exponent, so I have 6x squared, and divide by that value. And let me write a little aside here. 5, that's not a 5, 5 is equal to 5x to the 0. I can use the same rule, even if I don't think through that the antiderivative of 5 is of course 5x, because the derivative of 5x is 5, I can think of it this way. I can add 1 to the exponent and get 5x to the 1st over 1. So I do that. And this is going to be evaluated from 1 to 3. And let me reduce what I can. So this doesn't reduce at all, unfortunately. So I have x cubed over 3. However, 6 over 2 reduces, so I get 3x squared. And this dividing by 1 doesn't change anything, so that's a 5x. And now I'll put in the 3. Upper limit goes in first. So I'll have 3 cubed over 3 minus 3 times 3 squared plus 5 times 3 minus, and I'll put in the 1. 1 cubed over 3 minus 3 times 1 squared plus 5 times 1. And I'll do this all out first. So 3 cubed is 27, divided by 3 is 9. 3 squared is 9, times 3 is 27. 5 times 3 is 15. 1 cubed is 1, divided by 3 is 1/3. 1 squared is 1, times 3 is 3. 5 times 1 is 5. And now I have to clean this up a little bit. So 9 minus 27 is negative 18, plus 15 is negative 3. Now a little bit of a side. I'll show the work here, even though many of us can probably get through it without. I need a common denominator here, so this is going to be 1/3 minus 3 is the same as 9/3 plus 5 is the same as 15/3. And that's going to give me, let's see, negative 8 plus 15 gives me positive 7/3. And now I need to get a common denominator as well. So recall that, I guess I'll change colors. Negative 3 is the same as negative 9/3 minus 7/3 gives me negative 16/3. So it can get a little annoying with fractions when you're dealing with these terms. One last example. What do we do about this? Now this isn't a polynomial, but it can be written as a power function. So in here, I'm going to rewrite the 4th root of t as, so integral from 16 to 81, t to the 1/4 power. And now, in order to get the antiderivative, I add 1, so 1/4 plus 1 is 5/4, and I divide by 5/4. Now, in here, if I'm going to be doing this by hand, which I will be, I don't want to think of this as dividing by 5/4. So when you divide by 5/4, that is the same as multiplying by 4/5. So 4t to the 5/4 over 5 evaluated from 16 to 81. And the fun continues. Let me change colors to make it all pretty. So I'll put in the 81. So I have 4 times 81 to the 5/4 over 5 minus 4 times 16 to the 5/4 over 5. So now we have this case, and again we'll do this all by hand, 81 to the 5/4. And I don't know exactly why, maybe I'm missing something here, but a lot of times when this is taught, it's taught to students as the 4th root of 81 to the 5th power. Now, I don't know about you, I'm not using my calculator right now, I don't want to do 81 to the 5th and then take the 4th root. So instead, I'm going to take the 4th root of 81 first, and then do that to the 5th power. I'm going to get to a smaller value if I can, and then go there. So whenever I see a rational exponent, I first try to reduce the exponent as much as possible. 5/4 is already reduced. And then, if possible, I'll take care of the denominator, which gives me the root, first, to make the value smaller, and then use the exponent to, the numerator, which will be the power, to make it larger. The 4th root of 81 is 3. 3 to the 5th power is 243. I'm going to do the same thing for 16 to the 5/4. So 16 to the 5/4 is going to be the same thing as the 4th root of 16 to the 5th. And the 4th root of 16 happens to be 2. 2 to the 5th is 32. And so now I can bring this in. So this over here will equal 4 times 243 over 5 minus 4 times 32 over 5. 4 times 243 will let me think. So 4 times 250 will give me 1,000, but this is 7 less, so 4 times that will be 28 less, which should give me 972 over 5. I could have just done that as 4 times 3 is 12, so 2 carry the 1. 4 times 4 is 16, plus that 1 is 7, carry the 1. 4 times 2 is 8, plus the 1 is 9. All right, 4 times 32, well, 4 times 2 is 8. 4 times 3 is 12, so I get 128 over 5. And hopefully I don't mess this up on the last part, so subtracting, I should get, let's see, 972 minus 128 gives me 844 over 5. Let me double check if I add this on. I get 5, 7. Yep, looks good to me. And that does not reduce, because reducing with a 5 is very easy. All right, I hope this helped out. Feel free to comment below if you do have any questions.